All right, we are going to have a little video here to help us practice writing chemical formulas. And as you maybe noticed by our little song as an introduction there, we're going to use the crisscross method. And we are going to have a nice, quick, easy way to see what ratios we need for two elements to chemically combine. So we're just going to do 3 examples. Here's the first one. We are going to combine aluminum and oxygen. And we're going to see what kind of ratio is needed to have the 2 elements, aluminum and oxygen, form a chemical bond. There's a couple simple steps. We need to first of all find the oxidation charges, the oxidation numbers for aluminum and oxygen. They are on our periodic table. And if we look at the periodic table, we can see that aluminum, number 13, is going to be have a charge of +3. And so we're just going to write here that aluminum has a charge of +3. We're going to go back and we are going to look at oxygen. Oxygen is atomic number 8, and it has a charge of -2. So we know the oxidation charges. Then we're going to rewrite the elements using their symbols, and we're going to put the positive one first. So we have the Al +3, O -2. Now we just need to crisscross the charges, use those as our subscripts, and then we'll understand what the ratio is for aluminum atoms to oxygen atoms when this bond forms. So the -2 is going to go down for aluminum, and the 3 is going to go for oxygen. That's our crisscross. So it is now Al2O3. We want to make sure that we drop the charges when we do the crisscross. We want to make sure that we put the numbers as subscripts. And that automatically works out. We know we have 2 aluminums. They're +3 each. That would give us a charge of +6. We have 3 oxygens, -2 each. That would give us a charge of -6. They always balance out. The charges will always balance out. So it's going to be Al2O3. All right, let's do our next example. A little bit more complicated, but not bad. Iron and iodine. So if we look on our periodic table, first thing we notice is that iron is here, and it's a transition element, it's a transition metal, and it does not have a set oxidation number. So what we need to do is look at the way iron is described here. We can see that it is iron 2. Whenever you see a Roman numeral, whether it's 1, 2, 3, or 4, you know that that is the oxidation number. So since it's not on our periodic table, we can get it from there. So we know that iron is going to be +2. Iodine, we go back to iodine, is going to be over here, and it is -1. So if we rewrite these, positive one first, Fe +2, I -1. Now we can do our crisscross method. Fe would be 1. We don't have to write the 1 because we don't write 1 when it's a subscript. And I would be 2. 1 atom of iron for 2 atoms of iodine. All right, last one. We're going to crisscross sodium and phosphate. All right, going to the periodic table, we know that sodium is atomic number 11. It's right there. It has an oxidation number of +1, just like everyone else in group 1 does. So we're going to put a +1 here. Now phosphate. Phosphate's a little bit different. Phosphate is not an element from the periodic table, but it is a polyatomic ion. Okay, and this is something that's important to understand. When it's not on the periodic table, you're going to find these polyatomic ions. And what you need to do is find it on a sheet. Hopefully you have a sheet similar to this. If you don't have this is the one that we use in our class. But you can see that phosphate is here, okay? And it is under the section that has a -3 charge. And the polyatomic ion for phosphate is PO4. And so what we're going to do is we're going to have phosphate as a -3. And when we rewrite it, sodium first because it's positive, we're going to put PO4 in parentheses and then -3. So whenever you have a polyatomic ion, just like we have here, it's going to go in parentheses. The charge for that polyatomic ion, it acts as one charged ion, so the charge applies to the whole thing, so it's going to be -3 for that whole polyatomic ion phosphate PO4. Once we understand that, it doesn't matter which element we're dealing with, which polyatomic ion we're dealing with, all of these would be the same. Ammonia is another good example. Ammonia is NH4. We would write it like this, in parentheses, and since it's a +1 charge, it would get a +1 there. Okay, any other polyatomic ion would work the same way, which is nice because now we can go back to our original method. We can go back to our original method, and we can still use our crisscross. All right, and we have Na3 PO4, and then really we would put the 1 out here, but remember, since we don't need to write that 1, it doesn't have to be there, but it's important. I wanted to put the 1 there just for a second because it's important to see that whatever this charge is, it goes outside the parentheses. You don't put it inside after the P or after the O, outside, because it applies to the whole thing. Okay, so we will get rid of this because we know we don't have to write the 1s, but we have sodium phosphate there. So hopefully this helps as far as using the crisscross method. I think it's a simple way to see how elements or an element in a polyatomic ion are going to form chemical bonds and how to write the formula.